All right, let us begin, cabbages. You are on page 119. We are starting a new unit.
Wait, did you mark the test?
No, of course I didn't mark the test. I got it today. I had to mark another blocks test. I'm going to mark it as soon as I can mark it. Most likely tomorrow during X block, as you guys aren't here till the afternoon. All right. Polynomials. I liked that font when I looked at it on the internet when I decided to download it, but I didn't like the way it came up. I'm not going to use it anymore. I don't like it so much I can't even remember its name. I got to get rid of it. But anyway, let's get back to down to business. A polynomial. First of all, that's a weird word. It comes from two Greek words, poly, which means many, and noma, which means numbers. So it really means many numbers. But what it actually is an expression. Now, before I go any further, do you people know the difference between an equation and an expression? I hope you do. This is the difference. Don't write this down. Well, you can't write anything down because we got the usual spinning wheel of death. X plus 7 equals 9. What can you do with that? Solve it and tell me what. What does x equal? 2. Excellent. That is an equation. It has an answer. X plus 7. What can you do with that? Nothing. That's an expression. It has no answer. Got it? So a polynomial is one of these. There's no equals anything. Okay? Okay. A polynomial is an expression containing, that shouldn't say containing, it should say containing at least one of the following. See if I can get it all written before it actually shows up. I did.
Does it show up on yours?
No. That's all written without anything to see. That's why I have L-E-A-A-S-T. At least one of the following. And I'm going to draw 3 different things here. And I'm going to call them by their real names, not by some fancy name or storytelling name. The first thing is it might be a constant. Now, you need a couple of examples of constants. What does constant mean in English, not math class? If I say something is constant, what does that mean? Repeats. What else we got?
It stays.
It stays. It never changes. Like I am constantly handsome.
No, you're not.
Yes, I am. And I am constantly intelligent. Yes, I am. And I'm constantly funny. Yes, I am. And I can tell all of this because all of you are smiling right now, which means you must. So, constants in English are things that don't change. In math, they are numbers. 4, 1/2, 2 squared. Anything that you can say is something. Everybody good? All right. That is one of the things that must have. At least one of the things it must have. It could also have a variable. Variables are things that do not have a solid value. They are unknown and they are changeable. How do we represent a variable in math class? We always use a letter, and we almost always use X, but it could be any letter, couldn't it? Does it have to be a letter? When we did trig, did we not have a variable that was not a letter? What was it? Theta, which was a Greek letter, but still. Anything that isn't a number, anything that represents a number. X, theta. Back when you were doing algebra in kindergarten, but they called it teaching you math, they used an empty box, right? 3 plus an empty box equaled 5, right? Everybody knows what a variable is, yeah? Yeah. And finally, the last thing that it might have is a coefficient. Which is a constant that multiplies. So an example of that would be 3x. Everybody cool? If it's got any one of those things, it's a polynomial. It could have all three. Everybody good? All right. A monomial. Mono, if you guys had been alive in the 60s, you would automatically know means one. Because back in the 60s, you didn't have stereo sound. You had one sound, one speaker that made one sound. You also might know it from monocles. Those things that the bad guys always wear in old movies if they're German. They always have a monocle. I don't know why. I tried to get my mom to let me have a monocle in grade 9. She said no. Because she said it would make me look like an old-timey German villain. If you're German, I'm not being any kind of ethnic, put down of you. I'm just saying that in the movies, all the Germans that are bad guys wore monocles. My right eye was bad. My left eye was good. My left eye was so perfect. My right eye was going bad. So I told my mom, why should we pay for 2 lenses when one isn't going to do anything at the glasses store? Just get me a monocle. And she said no. Probably a good idea, looking back.
Yeah.
Right? Probably the right move. I was angry with my mom, but I think that was the right thing for her to say. Nowadays, of course, if a kid said, I want a monocle. No. I want a monocle! No. Give me a monocle! Oh, all right. And every kid would be walking around like this. Yes, yes. Yes, Herr Doblados. Anyway, mono means one, which is any one of those things. Okay? Is one term, which could be 3. It could be x. I'm not going to use x because we always use x. It could be, give me another letter. W. Sounds good. It could be W. It could be 5Q. Any combination. It could even be 5Q squared. Is everybody with me? Okay. It could even be 5WQ squared. Why? Because it's one term, but why? There's nothing you can do with them. It's multiply, multiply, multiply. It doesn't change. At the end of this, you're going to get one value, yes? If you know what W is, you know what Q is, you're going to get one value. Everybody with me? And that's where it ends. So that makes it a monomial. A binomial, like a bicycle, has, or binoculars instead of a monocle. I see you. Is 2. Oh, I don't want to use gray, dummy head. Just like my hair. It doesn't hurt my feelings. I look in the mirror every day. It's not like, oh my God, Ash, I have gray hair. Every day I look in the mirror. It's not a big surprise. It's kind of like I look in the mirror and say, damn, that's a handsome man in there. I know. It's just true. No, it is. It's true. Handsome men get hot wives. It's all that there is to it. That's not really true. Just happened to work out for me. Binomial is 2 terms, which means it's 2 monomials. All right? So, If I have one monomial, I don't want to use x. If I have one monomial, p, and I have, oh, wait. No, I'll keep it red. You should see your doctor then. Never mind. Thank you. I'm appearing here till the end of June. And you have a second monomial. What would you use to connect them to put them together? Yes. Plus or minus. And here is why. If I tell you what P is, and this isn't here, then you have an answer, isn't it? P equals 6. Done. But if P equals 6, does this change the value at the end? Yeah, it makes it either 11 or 1, right? So this is what goes between terms. Everybody with me? So as long as there's a plus or a minus between each, you have a binomial. Everybody cool? Now, obviously, trinomial must be 3 terms. There is no such thing as a trinocular. So I can't use that. Huh? Yes, I know. But I was going with monocle, binocular, binoc. Trinoc, we don't have a third eye. It's a good thing. It would make it, hard to do this gag. Doink! Right? No, you couldn't, because then that's even easier to block. Right? Here's the move, though. If you doink someone in the eye and they block it, you go doink, they block, doink, they block, doink, they block, then you shake their hand and they say, oh, okay. They go doink. Don't poke people in the eye. It's only funny when it's the Three Stooges. Which is 3 monomials. So it could be a green coefficient and then a variable that could be squared plus or minus another coefficient, 4, and then another, it could be another variable, could even be the same variable. Let's give it a different variable. P plus or minus, and then a constant, let's call it 17. And that would be a trinomial. Is everybody cool with that? Yeah. I'll get to that. Don't you worry. Would I ever leave you hanging, Ash? No. All right, now, you will notice there's a bunch of blank space over here, yes? That is by design. Because I've spent now the last few minutes telling you what a polynomial is, so what will go in the blank spot? No. What a polynomial isn't. There are some rules that polynomials cannot follow. All right? Rule number 1. Restart the program. Rule number 1. 1. No dividing variables. All right? So this, 6 over x, no. Not allowed. Everybody cool? Easy peasy, right? If you see a variable in the denominator, not a polynomial. Number 2, which is related to no dividing variables. No negative exponents with variables. Why? Why is that not allowed? Corey?
Because then, in that case, you have to divide exponents.
Yes, because no, not divide exponents.
Make a fraction out of it.
You'd have to make a fraction, and the variable would go down to the bottom. Nice. right? That would not be allowed. Because that would become 1 over x squared. Now you got an x on the bottom. No dice. Right? And the third thing you are not allowed to have is no fraction exponents with variables. So this x to the 1/2 is not allowed. What is the common thread to our rules about polynomials?
It's all about the variables.
It's all about the variables. Because fractions are allowed, like 1/2 times x would be allowed, right? Because 1/2 is solid. You know what it is. All right? It's the variables that are important. Everybody cool? All right. Now, the next thing is not really important to the math. It's important to housekeeping. It's the way we write big polynomials out. Okay? I'll never care if you write your polynomials this way, but I do want you to understand the definition. All right? The degree of polynomials is simply this: the sum of the variable, again, it's variables that matter, the variable's exponents, oh, gotta stop, in any one term. Okay? So, what's important? Again, variables. And for degree, we only care about exponents. So let me write a couple of examples, see if you can figure it out. 4. Is that a polynomial? Yes. Why? No. Because it's a constant. What kind of polynomial is it? Monomial, because it has 1. What's its degree? No. Read the definition again. 0, because there's no variables. Everybody cool? That is degree 0. Everybody good? Okay. Let's alter it slightly. 4x. What's that degree?
1.
Degree 1. Why? The variable has an exponent of 1, even though it's not written. 4x squared. That's degree 2. 4xy plus q.
1.
Read the definition again.
1 and 1.
1 and 1, which is 2. That is degree 2, because 1 and 1, it's in any one term. And finally, the last example, because you've got it, 5x squared y plus 6xy. Degree 3. Degree 3.
Any one term, or did you pick the one term with the largest?
The largest. I didn't put that in the definition. Oh, I didn't. Sum of the variable exponents in any one term. The largest. Right there needs to be the word largest.
Where?
Right there. The largest.
Under where?
Yeah. The largest sum of the variables in any one term. Okay, now for you people, your polynomials are going to be so small that this doesn't really matter. But if you go further in math, you sometimes get some giant polynomials. And just to keep the math tidy, we like to write them in a special way. We write them alphabetic by degree. That's what this means. So if I gave you 3y cubed plus 2x squared plus 3x. Put that into the proper order. So alphabetical first. So what would go first, x's or y's? Oh my gosh, really? You only need the last 3 letters here, dude. Skip to the end. X, Y, Z. What comes first? X. So we got to put the x's first. Which has the highest degree? X squared. So to write this properly in a perfect world, it would be 2x squared plus 3x plus 3y cubed. Everybody got it? Do I care? No. You've seen it. I've done my job. Everybody okay? All right. Now, I'm going to take a moment to discuss algebra tiles because I hate them. Some people like them. Some people need them. That's fine. I'm going to take 2 seconds to explain it because, again, I'm supposed to. Whether I use them or not is another story. So algebra tiles, you remember what they are, I hope. They start with a little square like that and a little square like that, and one is colored in and one is blank. That means 1 and that means -1. Because in reality, if I tell you I have 5 M&Ms in my hand and I wanted you to count them and I had 7 M&Ms in this hand, what would you do in a math class to tell me how many M&Ms I had? You do 5 plus 7, right? So you would write 5 plus 7, and you'd know I have 12 M&Ms, yes? But this symbol doesn't actually mean 5 things, does it? That's only one thing. It represents 5 things. Everybody cool? That's why we use these. The real use they have, the best use they have, is on the very first day of polynomial multiplication. And they're the best way to show you why subtracting negative numbers is the same as adding. Those are the only 2 uses they have that I see, so I'm going to take 2 seconds to show you both of them. First, I got to remind you what they are. X, or 1, -1. If I put them together, how much do I have? 0. So if I put 1 there, how much is that whole group worth right now? 1. Everybody cool? Right there, please, my friend. All right, everyone's good with that, yeah? All right. The other algebra tile you have is a bar. And that bar is a little bit shorter than 5 of these. Because it's a little bit shorter, you don't know the exact value. And since you don't know the exact value, that gets an X.
Wait, didn't I learn this last year?
Yes, you did learn it last year. But where we're going with it, some of you didn't learn last year. So that's negative. And of course, there's the big one, which is an X bar, but it is stretched the width of an X bar as well. So much more effective if it actually works.
This is annoying. Super annoying.
X squared and negative x squared. Problem with algebra tiles is, of course, they are not good for anything past x squared. Are their exponents bigger than 2? Yeah, so they're kind of useless. But I like to show you how to deal with them anyway. Aight? Now, to use them, you simply do this. What do I have? Is that 5 a polynomial? Yes. Is it attached to something by multiplication? Yes. So that makes that a coefficient, doesn't it? Since it's multiplying, it's also a factor, right? Because anything in the multiplication question is a factor, right? So if that's one factor, then this must be the other factor, right? Right? Because brackets hold it together. That's all one thing. Yeah? So, if we were going to draw this out as a picture, and we're only going to do it like 4 times ever, right there, please, Gabe. Thank you. the factors go outside, just like when we're doing length times width, and the answer goes inside. So how would I draw positive 5? What would I need? You got all the examples right there. I need 5 little boxes, and I'm keeping gray because that's what I used for the first factor, right? How would I draw the second factor, which I said is red? One little box and a bar, right? Is everything positive? Yep, so everything stays unshaded. And the answer is 1 bar, 2 bars, 3 bars, 4 bars, 5 bars, and then 1, 2, 3, 4, 5. What's the answer? 5 bars, 5x, 5 of them, positive 5. That's my answer. You already know this from grade 9, but there's a reason I'm doing it. Everybody good? Algebraically means we're only using numbers and variables. This skill, number 3, is what works all the time. Because you can't use algebra tiles past squared. So we had 5, x plus 1. Now what that means is 5 times x plus 5 times 1. Now this seems really elementary, and it is, but for some reason, if I stretch this out a little bit, all of a sudden the fact that you can do this in your sleep, you forget how to do it. And I don't know why. So, what we have there is what is called the distributive property, because that 5 is distributed into the brackets. The coefficient is distributed into the brackets. Now, you have already seen this year. This is how we do exponents. What else do we use this for? Pardon me? Formulas? I can't hear you, Ayesha. I'm so sorry. Oh, well then, tell me you didn't mean to put your hand up and we'll move on. What else do we use distribution for? Science. Where does that 2 go? Goes to everything in there. So I have 2 atoms of sulfur and 8 atoms of oxygen. That is sulfate, yes. But in a sulfate molecule, in this aluminum sulfate formula, there would be 2 atoms of sulfur and 8 atoms of oxygen. And 2 atoms of aluminium for a total of 10 atoms. Right? So you all already know how to do distribution. From grade 9 and from science and from exponents. So there's no reason to not be good at it. The distributive property in math looks like this. X, some coefficient, whatever it is, and then in here are more terms. A plus or minus B plus or minus C. And how far could I go with this? Right? I can't go to infinity. A polynomial has to end. So I'm going to end at Z. And what happens is you get X times A plus or minus X times B plus or minus, and so on. Everybody good? It's easy peasy lemon squeezy. Down to X times Z. Right? Okay. Now, if we're going to show a picture, remember I said we're only going to draw 3 or 4 pictures. Show me a picture here. Factor 1 is X. How do I draw it? A bar. Factor 2 is 2 X's and negative 4. Big X squared. Negative wins. Negative. And what's the answer? 2x squareds minus 4x's. Super easy, right? People tell me they find them difficult. It's not that bad. Now, I also want the algebraic solution. Because we're taking notes, we're actually going to write it out. In reality, you wouldn't do what I'm about to do. But because we're taking notes, we're actually going to write it out. X. X, 2x minus 4. What's that really? X times 2x minus x times 4. X times 2x, 2 times 1 is 2, x times x is x squared, minus 4 times x minus 4x. And you can see we have the same answer. Yeah? I don't feel I need to do a picture here, do I? No. So what is it? We are going to write it all out because we're still doing notes. 3x, x plus 2 is really 3x times what? X plus 3x times 2. What's 3x times x? 3x squared. What's 3x times 2? 6x. Gouda? Okay, that is as far as everybody in BC had to go in grade 9. Some of your grade 9 teachers will have gone further. They had to go to there. Is everybody good to there? So if I gave you this, 4x squared y times 6xy plus 2x cubed, you could tell me the answer. What is it? Take your time, no rush. What's the first term? 24 x cubed y squared plus 8x to the 5th y. Now, would we write it that way if in a perfect world? No, we'd switch their places. Why? Because 5 is bigger than 3. But I don't care.
Wouldn't we solve it too?
Solve it how?
Simplify it, no?
How?
But you should add the x and
No, you can't. X cubed, x to the 5th. They're not like terms.
Oh, because they're 2 separate things.
Yeah.
We'll have to look back at that.
That's okay. I only have to ref 2 rugby games in that. Everybody can do this, yes? That's where grade 9 ended. Now we move on. For some of you, this will be new. For some of you, this will be still a little bit of review on page 121. This is the third drawing we are going to do today and the last one we are going to do in our notes. That's a factor, yes? And it's multiplying right there by that. So that's factor 1. That's factor 2. Where do the factors go? On the outside. First one is x plus 3. Second one is x plus 2. Fill it out. Big X. 1, 2, 3. 1, 2. 1, 2, 3, 4, 5, 6. What's the answer? The answer lives in the middle, so all you got to do is count now. What's that? x squared. What's all of these? Plus 5x's, because they're not colored in. And what's this? Plus 6. Easy peasy, right? Everybody good? Okay. If I'm going to do it algebra, I'm not allowed to draw it. So it's x plus 3 times x plus 2. If there was no 3 there, what would you do with the x? Pretend 3 isn't there. I'll erase it just to help you out. What are you going to do with that x? Where does that x go? Inside. So it's going to hit that one first to get me x squared, yes? And then it's going to hit that one to get me what? Plus 2x. Now, there's a 3. Now the x is gone. So what do I do with that 3? Same thing. It hits there to get me 3x. Why do I put the x's together? Because then I'm going to add them up. And then it hits the 2 to get what? 6. And then I add them up to get the same answer, yes? Which is x squared plus 5x plus 6. X squared plus 5x plus 6. This is what many math teachers have given the acronym FOIL to. How many of you have seen this last year? All right. I don't like this because when you hear FOIL, you start thinking only about this situation, which is binomial. FOIL only works for binomial times a binomial. Is it possible to have a polynomial bigger than 2 terms? Yeah. So this little rule is great for one situation and one situation only. Yet math teachers take a year on that. Because all of you have seen it, most of you have seen it, I'm going to take a moment with it too. What does it stand for? First, outside, inside. See how you all know it? Last. So you all know how to do FOIL, right? So that means if you actually know how to do FOIL, you could do this. Couldn't you? You should be able to. But I know from marking 17 years of math tests that this often gets done wrong. Even though you've spent 30 years with FOIL. The better way to talk about it is not calling it FOIL, but calling it what it is. What do you do with that x? Starts with a D, ends with an E, and has istribut in the middle of it. You distribute that x. Right? What do you do with that 3? You distribute that 3. So FOIL is still the distributive property, isn't it? So now that I have told you that I disdain the use of FOIL, and I've gone out of my way to draw it, and I've shown you a place where FOIL will not work, all of you should be able to figure this out now. What would I do with that x squared? Distribute it. How many times? Thrice. 1, 2, 3. What would I then do with that 7x? How many times? Thrice. 1, 2, 3. What would I then do with that 3? How many times? Thrice. Giving me 9 terms to add up. Right? It's the exact same thing. But we spend all our time yelling about FOIL, which only works here. But if you spend time practicing distribution, when does it work? Every time. Got it? All right. Show this as algebra. So, x minus 1, x plus 4. Show it as algebra. What's the first thing you're going to distribute? The x on the left into the binomial on the right, correct? So what is my first line going to be? What's x times x? X squared. And what's x times positive 4? Plus 4x. Lovely. Now I have to distribute the negative 1. What's negative 1 times x? Negative 1x. And in this case, I'm actually going to write it. Negative 1x. And what is negative 1 times positive 4? Negative 4. And then I combine them. X squared plus 3x minus 4. Does everybody see how it works? Now that I believe you and you have seen it to death, I'm going to give you a gift of a shortcut. Some of you will know this shortcut, some of you won't. What do you notice about that number and that number and that number? I'll say them in case you're having trouble reading them. What do you notice about negative 1, positive 4, and positive 3? 4 minus 1 is 3, right? That time you had your hand up, Aisha? I can't win. The last time I thought your hand was up and it wasn't. That time it was, or I thought it wasn't and it was. So you all noticed that, yes? Okay. What do you notice about, now I'm going to circle it in red when my pen works. What do you notice about red and red and red?
It's the positive and negative and the negative.
So tell me a mathematical relation between negative 1, positive 4, and negative 4. We added them to get the blue one. What did we do to get the red one? Multiplied them. That's the shortcut. Here's what it looks like with letters. If I have x plus anything, and remember it works with minus as well, and x plus anything else, then the answer, and it only works when there's no coefficient. X squared, and then it's plus or minus a plus b x, and then plus or minus a times b. Is everybody with me? That's the shortcut. So let's look up, and I'll prove it to you right now. I'll get right back to it, Louis. Relax. Is this x by itself? X and x, right? No, there's no coefficient, right? So the answer would be x squared, and then they're both plus, so plus, what's 3 plus 2? 5x, and what's 3 times 2? 6, and it was, wasn't it? Everybody understand? When does it work? No! Only when the first variable has no coefficient. So could I do it with this? Q plus 2, Q minus 5. Could I work it there? Why? Because there's no coefficient. So it's going to be Q squared. Now, what do I do with these two? So what's 2 plus negative 5? Negative 3Q. And then I multiply them. What's 2 times negative 5? Negative 10. And you've got the answer. Without foiling. But you can only use it in this case. Otherwise, you have to foil. Yes. What? Wait till tomorrow. Is everybody good? All right. Now, your job is page 122 and 123. You will notice that the first two instructions, or the first two on 122 and the first one on 123 ask you to draw. You only have to draw one of them.
One of the three.
One of the three. I don't care which one you draw. But you have to show me you know how to draw. Okay? I will call your attention to one thing before we go on. What does that mean? X times x, right? What does what does that mean? 4x times 4x. What does this mean? 3xyz squared. 3xyz times 3xyz. Right? Everything in the brackets is squared. Right? Now, I'm going to highlight something that I'm not going to say anything else about it because I just reminded you. Okay? Okay. Page 122 and 123, that's your work for now. And if it doesn't get done, that's your homework. Everybody good? Go.
Oh yeah, I also.
Of course.
I think it's all this. The question is.
Those are the first two. If you've done them right, because you had to draw one of them, or most of you probably chose one of them to draw. If you got both of them right, then you know what you're doing. Okay?
Okay.
Now, are the rest of these shortcuttable? They are, aren't they? So it's going to be x squared. What's 3 minus 2? 1. So positive 1x. And what's 3 times negative 2? Negative 6. Done. X squared. What's 9 minus 7? Positive 2x. And what's 9 times negative 7? Negative 63. X and x, so I can shortcut. 9 plus 4, 13x. 9 times 4, 36. And lastly, x squared negative 2 minus 4. Negative 6x. Negative 2 times negative 4. Positive 8. And that's all the right answers to 122. You do 123 for homework.